So example 6 is going to deal with the polar form of a complex number. So you take your complex number, which is again like rectangular, and we're going to write it now in polar form, or what's sometimes called trigonometric form. And it's this. And now you might be going, wait, no, what in the world is that? Well, I want to remind you that this is rectangular, where this is kind of like the x value, and this is the y. And if you remember, x is equal to r cosine theta, and y is equal to r sine theta. Notice what's common between these two is they both have an r. So the r gets factored out. The y contains an I, so this is the y. When you factor out the r, all that's left in place of x is cosine. And when you factor out the r, all that's left is the sine. So since y had an I, it'll have I sine. And so you can, again, use this form as we go through. Again, here's a bunch of cheat sheets to help you out, but these two represent the same thing. This is in rectangular form. This is in polar form. So with polar form, the only thing different is they're going to factor out that r. So let's practice some of these. Example 6, write the complex number here in polar form and label the complex graph accordingly. Remember, this is our real portion. This is the real. This is the imaginary. I stands for imaginary. So I would go square root of 3 to the right. I'm just going to say it's right here. Let's just say that's the square root of 3. And then because that's just an I, let's say we go up 1. My point should be right there. That would be my point for this complex number z. If I wanted to draw a graph of this, I would have that. And this would be my A portion, which is the square root of 3. This is my B portion, which is 1. So this right here represents the modulus of z, or the magnitude. This is the B value of 1. This is the A value of square root 3. Okay, so A is square root 3. I need to put that on there. B is 1. To find your R, remember what you do is you take the square root of x squared, or in this case, a squared. So square root 3 squared plus the y squared, or in this case, the b squared. So here, this square root and this square cancel. And so it's the square root of 3 plus 1 squared is 1, which just means it's the square root of 4, which is equal to 2. So my R equals 2. Now, my theta, what you'll do is the inverse tangent of, well, normally we'd say y over x, which in this case, this is the y, this is the x, this is technically b, this is a, so it's 1 over square root 3. Now that's a hand trick value. This is the same thing as square root 1 over square root 3. 1 is square root 1. So if you turn your hand upside down, because it's inverse, you're looking at, I need one y finger, I need 3 x fingers. That means I bend my ring finger. When I flip over my hand, my ring finger represents pi over 6. Pi over 6. So that's our value here, pi over 6. We're in the first quadrant, so I don't have to change that value. I don't have to add a pi. This is 1 pi over 6. This angle right here would be pi over 6. That's what the theta would equal here. And this modulus z would equal to, you know what? I just realized I put r there. I should say modulus z here. Okay, so in polar form. Oh, wait, no, we're going to write in polar form. So we would use letter r, which is equal to modulus of z. In polar form, what you would say, let me go back here just to show you. In polar form, you're going to say z equals r, parentheses, cosine theta, plus I sine theta. So the polar form would be z equals r, which is 2, parentheses, cosine of our theta, which is pi over 6, comma, no, plus I sine of pi over 6. That is the same form. If you don't believe me, just reduce it. That right there is our answer. And if you're going, nah, that's just something seems off on that. Well, if you think about it, you could reduce this. Again, bend your ring finger, flip your hand over. If you just, this is like a proof here. What I could do is I could say this is 2 times, and the cosine at pi over 6 is the square root of 3 over 2. plus I, the sign would be the square root of 1 over 2. When you distribute that 2 through, it cancels both denominators, and so what's left over is the square root of 3 plus I square root 1. And that right there is the same thing. Square root of 1 is 1. So it's just I times 1, which is I. Notice that's exactly where we started off. 3 plus I. So that's how you write your answer in polar form. Now go try deal wells 1 and 2.